Okay, so till now we've been talking about conditional probabilities, but we haven't shown you clearly the connection between conditional probabilities and predictive analytics. After all, naive Bayes is a predictive analytics technique. In fact, a technique specifically, it's a classification technique. But let's see the connection between conditional probabilities and predictive analytics. Okay, so the diagram that we've been looking at in terms of the countries and buyers and non-buyers so far, that can also be expressed like this, right? So you've got Canada, which is the country. There are 3 buyers, 7 non-buyers, for a total of 10 Canadians. US has 4 buyers and 13 non-buyers for a total of 17, and so on, right? So that same information, which we looked at to calculate conditional probabilities, we can look at it like this as well, right? So we can now look at this as if it's a predictive analytics problem, right? So we can think of the country as a predictor attribute, and whether a person is a buyer or non-buyer, the status, as the target attribute, right? So we can look at it that way. So given a person's country, can we determine the probability they're a buyer and the probability they're a non-buyer? Of course, those were the conditional probabilities that we calculated, right? That is probability of buyer given Canada, right? So when we say given Canada, essentially you can think of whatever is given as the value of the predictor attribute or values of the predictor attributes if there is more than one. And then we can talk about the probability that is being calculated as probability of a target attribute taking on a certain value, right? So clearly, whatever we've been looking at so far is closely related to predictive analytics. Okay, so given a country, we can use this table to calculate the conditional probability of being a buyer or non-buyer, right? So given a person is from Canada, probability of being a buyer is 3 by 10, probability of being a non-buyer is 7 by 10 because there are a total of 10 Canadians. Okay, so we can calculate all of those. So clearly what we've been looking at till now is really something in predictive analytics. Okay, so country is a predictor and buyer, non-buyer is the target. Okay, so if country is given to be US, then probability of buyer is 4 by 17, non-buyer is 13 by 17. Okay, so you can look at it like this. So given, suppose you have a bunch of people whose countries you know, Canada, Mexico, Canada, etc. Given that, you can calculate what is the probability of them being a buyer, a non-buyer, using this table. Now let's add one more attribute. For example, in addition to country, let's say we also have their gender, male, female, etc. And let's say that the data is broken up like this. For example, in Canada, we've got one buyer who's a male and 5 non-buyers who are male. So you've got 2 buyers who are female and 2 non-buyers who are female. Okay, so the same data is just broken up further and the totals are still the same. It's 10 people in Canada, right? So now we can think of the country and the gender as predictor attributes and the status, buyer or non-buyer, as the target attribute. Okay, so the predictors are country and gender. The target is status. So given a value for country and gender, we can calculate what is the probability of somebody being a buyer, non-buyer, right? So for example, given that a person is Canadian, that is country equals Canada, gender equals male. Now what is the probability of being a buyer? Well, country, Canada, gender, male, there are a total of 6 people of that description. Out of that, 1 is a buyer. So you can say probability of being a buyer is 1 by 6, non-buyer is 5 by 6. So you can calculate these kinds of things. So again, taking another example, suppose you've got a person whose predictor attributes country and gender are Canada and female respectively, right? So what we are talking about now is what is the probability given Canada and female, what is the probability that they are a buyer? Once again, we can calculate that from here. Given Canada and female, total of 4 people, 2 of them are buyers, so the probability is going to be 1 by 2, 2 by 4. Okay, so you can say given country and gender, what is the probability of buyer? Well, that's a classification model right there. Okay, so the kind of conditional probabilities we've been looking at are closely allied to predictive analytics, especially to classification. Okay, now this approach that we've just spoken about right? We were able to give values for the predictor attributes and compute probabilities for the target attribute. That's a classification model, right? Of course, it can work only when you have all predictors are categorical. And since we are talking about classification, the target is also categorical. Now, this method is called the exact Bayes method. Simply calculating the conditional probabilities, they call it the exact Bayes method. Okay, now this can work, right? So given the predictors, you're able to find the target, done. That is classification. Okay, so this is called exact Bayes. And the only problem here is that this can be used only when you've got enough number of cases for each combination of the predictor attributes, right? Suppose, for example, here, Canadian male, well, you've got only 6. Out of that, you're making a prediction. That may not be quite good. Whereas if you had 50 here, then you may say, well, that is quite representative. Okay, that's the only reason that one might not use exact Bayes. You might not use exact Bayes when you don't have enough number of cases to justify a reliable prediction. If you do have enough number of cases, that's fine. Okay. And of course, the premise for going for something other than exact Bayes, which is naive Bayes that we're going to discuss shortly, the premise for doing that is you will often be in scenarios where you just don't have enough data to apply exact Bayes.